Section 2.6, skewness, and then the mean, median, and mode, those measures of center that we talked about in our last section. We have four types of distributions that we want to consider here at the beginning of class, and the first one is a uniform distribution, and this is where, if you think about uniform, everything's the same, that's exactly what this means. This is when each of the values tends to occur with the same frequency. So that is a uniform distribution. A variable has a bell-shaped distribution when most of the values fall to the middle and then the frequencies tail off to the left and the right. It is symmetric, and in this case, the mean and the median and the mode are all equal. This word symmetric, I don't remember if we've used it yet, but symmetric means that you find the middle and then what happens on the right and left are basically mirror images of each other. I know we'll be using bars, but just to use this, the reason we call this a bell-shaped curve is you've got the most stuff in the middle, and then as you go further to the right and left, there gets to be less and less value, fewer and fewer values in those areas. A variable has a skewed right distribution when the distribution is not symmetric and the tail to the right is longer than the tail to the left. In this case, and we're going to show some examples here. Well, actually, let me just show an example right away. So skewed right would be kind of like this. And here's your mode. That's where it occurs the most often. Your middle, your median would be like somewhere right here. But then remember that mean gets pulled further because it's less resistant. So the mean gets pulled further. So in that case, you're going to have the mode is going to be the smallest of those. The median will get pulled a little bit to the right. The mean will get pulled quite a bit to the right when it's skewed right. Let me erase this so we can see better. When it is skewed left, that is a distribution that is, again, not symmetric, but this time the tail to the left is longer than the tail to the right. In this case, everything would be exactly flipped. The mean will be the smallest, and then the median, and then the mode will be the largest one. Here are some pictures of bar graphs showing these different types. So you can see the first one here is uniform. All those frequencies are basically the same. In this case, it's probably a perfectly uniform data set, but uniform in general means they're all right around the same level. Next, we have bell-shaped, and notice it's highest in the middle, and then it slowly falls on either side. It's not perfectly symmetric, but again, we're looking for the general shapes, and we see that that's bell-shaped. Where we have skewed to the right, notice here's your highest point, and then to the left, it's very short, but to the right, it goes a lot further to the right. And you've got these things sticking out here. You've got a lot more categories going to the right. That's what makes it skewed right. And then just the opposite for the last one, it's skewed left. From the middle, you've got, what, 1, 2, 3, 4, 5, 6 categories to the right, but only 3 categories to the left. 1, 2, 3, 4, 5, 6, yeah. So that's what makes it skewed right or skewed left when you have a lot more categories, a lot more data going in one direction than the other. That one is pretty straightforward and quick. Section 2.6, there are 5 graded problems there. Please remember to ask me for help or send me a message if you get stuck and have a question.